And today I'll be speaking about super node and super mesh. What is the difference between the earlier questions and this question? I'll make it clear to you. And after which I'll be uploading PPT or a PDF, rather with more number of problems, worked out problems, so that you can look into those and then go to your assignment number 2. Okay. So let me. So we were discussing about node voltage analysis. Now, if you look into this, you will see one speciality. All the problems that we discussed till now regarding node voltage analysis, you had a current source only, because all these sources are current sources, so that they could be directly taken here. Okay. So it was easy. So you just applied, what did you apply? We applied KCL to node V1 and V2 and then wrote these equations, or directly wrote the matrix equation, as the case may be. So in node voltage analysis, you are applying KCL alone. And remember, you had only cases where you had current sources alone, because you are writing equation in terms of I1, I2, etc., which are coming on to the node and which are going away from the node. Those KCL was being applied. Suppose another condition comes, say for example, suppose I take this, you have to draw along with me and note down the points. I may not give the note for you in this case, because I am giving you PPT or PDF. So suppose I have a circuit like this, okay, where I have a voltage source instead of current source. I'm having a voltage source. This is say 4 ohm. This is say 2 ohm, 8 ohms, 6 ohm. This is a voltage source, plus minus 10 volt, plus minus 5 volt. And you are asked to find out something through node voltage analysis. And you know that there are two nodes. One is V1, another is V2. Yeah, there is a third one, V3. And you can even have a V4, which I'll take as a reference node. This is at zero potential. That is what I always take as zero potential. Now, let me put certain currents also. Let this current be I1. Let this current be I2, I3. These are currents which I am arbitrarily giving. I am giving myself. Arbitrarily means by myself. It is not mentioned in the circuit that is given. And I can put any direction. I can put the direction in any manner. I'm just putting it like this. It can be in any direction, because finally when I get the answer, if I1 happens to be a negative value, -5 or something, I will always know that I1 is not in the direction that I had assumed. That is so. So now, case 1. Case 1. Consider this voltage source, this 10 volt source. Now this voltage source is connected between V1 and the zero potential, which means what is V1 equal to? The node voltage V1. Node voltage V1 is equal to 10 volts itself, because it is connected between a non-reference node and a reference node. This is the same node. So V1, or the node voltage V1, this node voltage V1 is the same as the source voltage 10 volt. But case 2. Suppose you consider the other case. Suppose the voltage source is connected, say the 5 volt voltage source is connected between which all nodes? V2 and V3. V2 is not a reference node, nor is V3. V3 is also not a reference node. So this is called a super node. The two reference nodes together form a super node. Okay. So because the voltage sources have come in, because there is a super node, we may have to apply KCL as well as KVL. In a node voltage analysis, we usually apply only KCL. But in this case, you might be needed to apply KVL also. So let us first apply KCL. When you apply KCL, remember this is taken together as a node. Okay. So by applying KCL, you will get I1. I1 is going into V2 and V3 are completely together as a single node. Okay. It is going, so I1 going in. Another current which is going into the node is I4, which is equal to two currents are going out of that node. V1 and V2 and V3 are together one node, one super node. That is equal to I2 plus I3. I want to, I hope you have understood. Should I explain this once again? Anyone? I don't know. Anthony?
Yes, ma'am.
Did you understand this, how I wrote equation number 1? Or else tell me, I'll explain once again. Do you want me to explain once again? Anthony?
No, ma'am.
Okay. So, you have written KCL as you had written for any other node voltage analysis. But it is not sufficient. You have not brought in that. You do not know the voltage across 5. You do not know V2 and V3 separately. So, you have to write the KVL or this is equal to this I1 we can write as I1 is a current flowing through 2 ohm. So, that is V1 minus V2 by 2 plus I4 is a current coming from V1 to V3 through 4 ohm. So that is I4. That is V1 minus V3 by 4 is equal to I2 is a current flowing from V2 to the reference potential V4 through 8 ohms. So that is V2 minus 0 by 8 or V2 by 8 plus I3 is a current flowing from V3 to the zero potential through 6 ohm. So V3 by 6. On rearranging, you will get, or that is equation number 1. That is, let it be. I'm not going to do the whole problem. Now I am going to apply KCL. Sorry, KVL. Now, first I applied KCL to the node. Now I am going to apply KVL. When I apply KVL, let me draw this once again. I'll be just taking this alone. This part alone, I'm drawing this in an elaborate manner. Plus minus 5 volt. I have V1, sorry, V2, and I have V3 here. I'll be and this is a reference node. So this is plus, this is also plus, this is 0 or minus. So I am taking an arbitrary like this. I'm going in the clockwise direction and I'm applying KVL. So I'm not thinking about 8 ohm resistor or 6 ohm resistor, nothing. I'm just writing in terms of V2. So I don't require that 8 ohm. I2 and 8 only makes V. So I just require the voltages only. So going around this loop in the clockwise direction. Here I'm going from a negative to positive, or it's a voltage rise. So minus V2. Again, here it is a voltage drop. So plus 5, it's a voltage. So 5. Then V3 I'm going from plus to minus, or I'm going for a voltage drop. So this is again plus V3 equal to 0. That is equation number 2. Now what I do is I use equation number 1 and equation number 2 to find out the values of V1, V2, V3. V1 I know is 10. So the only two unknowns are V2 and V3. You have two equations, equation number 1 and equation number 2. Using equations 1 and 2, you can find out V2 and V3. It is as simple as that. Let us do one problem on this. You can try this. Okay. Same kind of problem, but with a little bit difference. This also I want all of you to understand, that is why. Draw along with me. This is another current source, 7 ampere. I'm having a 10 ohm resistor here. So naturally, I am having, how many nodes are there? This is not a node, this is the same thing. So this is V1. And I am having another node, V2. And I am having a reference node, V3, which is 0 potential. Now I am asked to find out the node voltages V1 and V2. Find V1 and V2, the node voltages V1 and V2. Again, as you can see, all of you should listen. I'll give you time to write. As you can see, there is one current source, there is another current source, but there is a voltage source as well. When you are thinking about node voltage analysis, you are mainly discussing about KCL. Had there been only current sources, you would need apply KCL only. But because that a voltage source comes in, and this voltage source is connected between two non-reference voltage source, node voltages, and not directly to the reference voltage, you have, this means that is a super node occurring there. This is a super node together. So this is a super node. Super node consisting of two voltage sources, sorry, not two voltage sources, two node voltages, sorry. Two node voltages, namely V1 and V2, and also a 10 ohm resistor. Why did I write the 10 ohm resistor? Because the 10 ohm resistor is connected directly between V1 and V2. In the previous problem, it was different. That 4 ohm or some, that was connected across so many other resistors also. In this particular case, V1 and V2 are the two nodes across which a voltage source is connected. So they naturally form a super mesh or super node, and that super node is connected together with a 10 ohm. So that 10 ohm also you have to take it as a super node. It's as being in the super node, which means I need it. It automatically means I needn't take any current here, I1, some I4 or something, because they together form one node. So I need be concerned about this current. This current. So that current I know is 2 ampere, because here I have this current I know is 7 ampere. Now towards that, and then you have these two arms or these two resistors through which I can indicate, say, I1 in this direction and I2 in this direction. You can even indicate it in the opposite direction. Okay. Hope this is clear. Manasilayillengi parayanam. Akash Shashikumar. If you didn't understand, I'm all right. I'll just explain it more. Akash.
Yes, ma'am.
Did you understand, Akash?
Yes.
Is that very clear? Crystal clear?
Yes.
Okay. So then I'm going to apply KCL to the super node. If I apply KCL to the super node, so 2 ampere is going in. 2 ampere is the only current that is going in. I1, I2 and 7 ampere also. Okay. So I can write 7 ampere, sorry, one, just correction is here. 7 ampere, because otherwise the answer will go wrong. This was okay, but otherwise the answer. So in the question, they have given 7 ampere in this direction. So this is 7 ampere. Okay, please correct it. The other was also an equally correct question, but I have written the answer for this. So applying KCL to the super node, I'll get 2 ampere is the only current going in. I1, I2 and 7 ampere are going out of the node. So 2 is equal to I1 plus I2 plus 7. That is 2 is equal to, what is I1? I1 is V1 divided by 2. V1 by 2. What is I2? I2 is a current flowing from V2 to the reference node. From V2 to the reference node through 4 ohm. So it is V2 by 4 plus 7. Or you will get finally by modifying, you will get 2V1 plus V2 is equal to 20. Equation number 1. I multiply throughout by 4. So this is your first equation. I hope you have written down, or else I'll give you 1 minute. Now it's 11:20. I'll wait till 11:21. Let this sink in. You should understand this. Okay. Now, as you can see, my first equation contains two V1 and V2. Both V1 and V2 are unknowns. When I wrote by writing KCL, I got an equation in V1 and V2. Now I have to search for some other equation where I get an equation in V1 and V2. So that I'll end up with 2 equations and 2 unknowns. So it is easy for me. So what can I do? Next thing that I'll do will be to apply.
Ma'am, excuse me, ma'am.
Yeah.
Ma'am, 2V1 plus V2 is equal to minus 20, alle.
Minus 20. Okay, correct. Minus 20. Minus 28 plus. Okay, minus 20. Correct. Thank you for the correction. I'm so happy that you corrected me. Okay, other. Now the second thing is to apply KVL to the same supernode. How will you apply the KVL? Again, as before, you just take this. You have a 10 ohm resistor also. And then you take a clockwise. I am satisfied by applying this to this loop alone. Okay. This is minus plus. This is plus because it is 0 here. So let me take it in the clockwise direction. In the clockwise direction, if I am taking V1, I am going for a voltage rise, so it is minus V1. Here again, it is a voltage rise, so minus 2. This is 2. Here I am going from plus to 0, or it is plus V2 equal to 0, which I'll get as minus V1 plus V2 is equal to 2. Equation number 2. Now I have 2 equations, one in equation 1 and equation 2. Now it is very easy for you. You can find out V1 and V2. Okay, no, let me not go for that. So solving equation 1 and 2, you will finally end up with these values. V1 is equal to minus 7.33 volt. V2 is equal to minus 5.33 volt. I hope you know how to solve these. 2V1 plus V2 is equal to minus 20. Cramer's rule is not needed here. Very easy otherwise. minus V1 plus V2 is equal to 2. You just subtract between these two, you will get 3V1 is equal to minus 22. V1 will be this, and then from the other equation you can find out V2. Now, the question may not be to find the node voltages. Question can even be to find out the currents. So you can find out the current. What is current I1? What is current I1? I1 is V1 by 2. So V1 by 2. I2 is current V2 by 4. That also you can find out. Now, note one thing. A very important thing to note is that this 10 ohm resistor doesn't make any difference at all. This 10 ohm resistor here does not make any difference because of the presence of the supernode. 10 ohm resistor doesn't have any say in the whole circuit. That is a very important point that you have to remember. So what did I discuss now? Today, what the discussion was regarding supernode. Supernode means in a node voltage analysis, normally all the problems that we did in the previous class had only current sources. In node voltage analysis, you will be applying KCL only. If it's a current source, then it was very easy to take that current in the equation. One KCL will do the whole, and you can even write taking two or three nodes. It was very easy for you to write the matrix equation in terms of conductance. Or else you can write the equations and then convert it to matrix. And once a matrix equation was obtained, then you could solve it by Cramer's rule. Now, there may be cases where you get voltage sources also in the circuit. And if you want to apply node voltage analysis, if the voltage source is connected between a node voltage and a reference voltage, then it's okay. It was easy. V1 is equal to this. That node voltage is the same as the voltage source. But if the voltage source is connected between two non-reference voltages, node voltages, then you have to consider it as a supernode and apply KVL also to the supernode. Apply KCL to the supernode, consider both nodes as one and then apply KCL to the supernode and also apply KVL to the supernode, and so that you will get two equations which can be solved to get the other unknowns. Similarly, in mesh current, that is a very easy. When it comes to mesh current also, it's easy. In mesh current analysis, you used to apply KVL. In any, you take each mesh and apply KVL. So, for example, you used to have meshes like this, okay, and there you were given only say 20 volt, 6 ohm, 10 ohm, 2 ohm, another resistor 4 ohm. You were given only voltage sources there, so it was easy for you to apply KVL. But suppose I provide a current source as well. If I put a current source, say 6 ampere, then it is not, you cannot apply KVL here because you do not know what is the voltage, whether it's a voltage rise or whether it's a voltage drop, or how much is that voltage across that 6 ampere voltage source, current source. So here you need to apply that also, the KCL also. So because, for example, I'll take a mesh like this, mesh like this. I'll take a mesh which consists of, say, I'll just eliminate. This is a difference from how you do in node voltage. I'll eliminate this whole arm of the network and then just take this much. 6, 10, 4, and the voltage source. This is 6 ohm, 10 ohm, 4 ohm, plus minus 20 volt. This much is I1. This much is I2. I eliminate this portion and then apply KVL. Then I apply KVL itself. When I apply KVL, it will be here. I am going from, it is a voltage rise, so it is minus 20 plus I1 into 6 I1 plus 10 I2 plus 4 I2 equal to 0. I hope this is clear. This portion I have taken, this portion I have taken, this portion also I have taken together. So this I will end on rearranging the terms and adding the similar terms. I'll get 6 I1 plus 14 I2 equal to 0. Equation number 1. Okay. Then I apply KVL also. Where do I apply KVL? I apply KVL to this node. Yeah, time is over. I'll just take 1 or 2 seconds more, 1 or 2 minutes more. KVL to this node where the meshes intersect. Okay, so there I can see that I1 is a current going out of the node, I2 is coming in, 6 ampere is also going out. So I1 plus 6 is equal to I2, equation number 2. Hope this is clear. Someone should answer me or else. Anuja?
Yes, ma'am.
മനസ്സിലായോ അനുജ? ഈ equation number 2 എഴുതിയത് മനസ്സിലായോ?
മനസ്സിലായി മാം. അത് KCL,
sorry, KCL, correct. Anuja, correct. You are correct. KCL, yes. I1 going out of the node, I2 is coming in, 6 ampere is going up. So this is equation number 2. Now you have ended up with equation 1 and equation 2 and 2 unknowns, I1 and I2. Can you find out I1 and I2? You can. Just like before, and you will end up with values. I1 is equal to minus 3.2 amperes and I2 is equal to 2.8 ampere. That is the final answer that you will get. Minus 3.2 means you have taken I1 in this direction. It is minus 3.2 means actually I1 in the actual circuit will be flowing in this direction. That is all. No problem. Hope this is clear. So this is called a super mesh. This is called a super mesh. Okay. So all these will be dealt with in the PDF that I'll be giving you. So yeah, that completes our module 1. If you have any doubt, you can ask me in person or even now. You can wait and ask me. No problem. Thank you.